Now let's start illustrations on this chapter, Geometrical Optics. We'll not do the very basic questions, the formula based ones, because we have dealt a lot on formulas, and I think it's better that we move on from the formula based questions to the more conceptual questions. Yeah, we'll gradually move on to the difficulty level and we'll be dealing with all the questions. So let's move the first question. The first question says that you have a concave mirror, and that concave mirror is such that I have placed a U-shaped wire here. The dimension of this U-shaped wire is 10 centimeter throughout, which means this dimension is 10 centimeter, this dimension is also 10 centimeter, and this also 10 centimeter. The radius of curvature of this concave mirror is 20 centimeters, and I have kept this U-shaped thingy 30 centimeter away from the pole. I mean, this point is 30 centimeters away, so this would be 40 centimeters away naturally, and the radius of curvature of this concave mirror is of 20 centimeters. So by using sign convention, R comes out to be minus 20 centimeters, right? What we need to find out is what would be the length, total length of the U-shaped wire image. I mean image of the U-shaped wire, not the object. Object definitely has 10 plus 10 plus 10. So length of the object is 30 centimeters. Length of the object is equal to 10 plus 10 plus 10 equal to 30 centimeters, right? And it is also situated 30 centimeters away from the pole. What you need to be worried about, or rather find, is length of the image. How do you approach this question? Simple mirror formula. But how would I use it? That's the question. Now, if we find out the position of the image of this point, then by using the magnification formula, I can also find dimension of this vertical line. So this is sorted out. Then similarly, I can find out the location of the image of this point, and magnification formula would give me the dimension of this wire too. So these two are sorted out. What about the lower, the horizontal wire? Now if you just think it through, all the points from here to here are away from the radius of curvature. So they would definitely be forming in one sequence. There won't be any discontinuity in the formation. So if I can find out the position for this and subtract them, that would give me the horizontal dimension too. So I have horizontal dimension, vertical dimensions, so I'll add them up. That would give me the length of the image. Let's try to proceed it from that angle. I'll take this as my first point, this is my second point. So I'll take U1 for this and U2 for this. So if I use the formula 1 by V, so 1 by V1 plus 1 by U1 is equal to 1 by F, which is half of radius of curvature, so minus 10. So 1 by V1 plus 1 by U1. U1 is minus 30. equal to 1 by minus 10. What does this give you? This gives you 1 by V1 is equal to 1 by 30 minus 1 by 10. Upon further calculation, this gives you 30. There's a 1 over here, and then there is a minus 3 thing over there, right? Then you have minus 2 upon 30. Invert it through. You'll get V1 as minus 15, which means 15 away from here. What about V2? Let's use the same formula again. If you use the same formula again, what you will get is 1 by V2 plus 1 by U2 is equal to 1 by F. Put in the values, you'll get 1 by V2 plus 1 by U2 is 40 from your Y, 30 till here and 10 more, so 40 minus 40. It's 1 by minus 10. This gives you 1 by V2 as 1 by 40 minus 1 by 10, which is 41 minus 4, which is minus 3 upon 40. Inverted through, you'll get V2 as 40 by 3 with a negative sign. This is roughly equal to 13.33. 13 3 to 39, so 1 by 3 is 0.33. Now, V1, V2 is giving you the location of these two endpoints. If I subtract them, I get the horizontal length. So horizontal length is, I'll just write a thing. Horizontal image length essentially. Mod of V2 minus V1, that would be equal to 1.67 centimeters. Just say centimeters. That would make more sense, or else you'll get confused. Now, what about the other lengths? I need to know the magnification at this position. The magnification at this position, or rather M1, is equal to simply minus V by U. So minus of this thing, minus 15 upon U, which is 30 minus 30. This gives you minus half. So half is the magnitude of magnification. Minus doesn't make any sense because I just need the length, right? So minus plus has no relevance for me. Just a mod M1 is relevant for me. So this implies that this guy over here, 10 centimeters standing at position 1, would be essentially equal to 10 centimeters into half. I'm just taking mod M1 value. This would be your 5 centimeters. Similarly, I can also calculate the magnification at this position, which would again be minus V by U, but here it is minus V2 by U2, which would be equal to minus of V2 is how much? Essentially minus 40 by 3. So V2 is minus 40 by 3. What is U2? U2 is essentially 40 with a negative sign. That gives you how much? Minus 1 by 3, which means it would be of 1/3 length, this 10 centimeter guy. So this implies that the other length, I'll just write this thing down over here. The other length, or just write this thing as your L1, this is L2, this is L3. So this gives you L3 image length. This guy gives you L2 image length. So this is your L2 image length. Now I'm worried about is L1 image length. So L1 image length would be equal to 1/3 mod of M2, 1/3 into 10, which is equal to how much? 3.3 centimeters roughly. So now I have L1, L2, L3. If I add them up, I'll get the length of the image. That would be equal to, just write the values down. L1 is 3.33, L2 is 5, L3 is 1.67. Obviously 3.33 and 1.67 would give you 5, and this is a 5. So I have 10 centimeter as my final length. See, what I've done is I've divided this question into 3 steps. First, the linear dimension, which is essentially the difference of the images of these 2 points, because inside is a continuous variation. Then the magnification of this gives you the dimension of this 10 centimeters, which is 5 centimeters. Magnification comes out to be half. Minus half, so minus is of no relevance for us. I just need the length, not the direction of the length. Now this value, magnification, is 1/3. So 1/3 of 10 again is 3.33. So if I add 3.33 from here, for this I have 5, and for this I have 1.67. So if you add them, 1.67, 3.35, get 10 centimeters. So this is the length of the image of this 30 centimeter U-shaped wire, if seen from a concave mirror of radius of curvature 20 centimeters. Let's move to the next illustration. In the next illustration, what we have is again a concave mirror, but we have kept it like this. It is filled with water. Up till height h. I mean, this is, as in we have kept the thing as like this, concave mirror, and filled with water. As there's a depression over here, up till height h. This is water. The radius of curvature of this concave mirror, magnitude wise, is r. If you draw principal axis like this, there would be something like C over here, which is your r. What you need to find out is how high a point image, rather object, should be kept here in this principal axis, near to principal axis, not at principal axis, because the moment you keep an object at the principal axis, the ray would proceed like this and turn back by normal incidence in the same line. So that's not required for us. What I need is slightly away from principal axis, slightly away. So by how high it should be kept so as the image is formed on the object itself. Now think through again. If the image has to be formed on the object itself, my rays should retrace their path. Only then it is possible. Just think it through. If rays are not retracing their path, why would the image be formed on the object? There's no point, right? My ray would go to some other point. But if my ray returns with the same direction, the same retracing, I'll again follow the object. See, if I start from this point, go like this, and reach here, and after reflection I take a different path, I would most probably not reach here. But if I take the same path, I'll reach here. It's like going to say that if you take the path from your home to school by following a fixed set of roads, and if you reverse your car and follow the same road, you'll go back to that same position itself. That's the logic over here. Now, if, let's say, I've kept it x above the water surface, right? If you kept it x above the water surface, what will happen is a ray which comes like this, it would get refracted, and as it is rarer to denser, it would be towards the normal, right? And after reflection, before reflection, the rays would be, thought as coming somewhere from up, and if the ray is pointing in this way, which means the ray is falling normally. In this situation, it would be normal incidence, and my light would just get reflected back in the same path. It would retrace, and the object and image would coincide, right? So this is a situation when your image would coincide with the object. The ray of light would retrace its path. Now, if I'm just slightly away from the principal axis, I can use the formula for apparent depth and apparent height. And in this situation, if the refractive index of this medium is mu and this is vacuum, so 1, then the apparent height here would be mu times x. This is x, right? So afterwards, what will happen is, I'll not see x as my height, but mu x as my height, right? If mu x is perceived, this is h, mu x plus h should be the radius of curvature of this concave mirror. Only in that situation, I'll have a retracing of path. Think it through. If this ray is going to the center of curvature, then the path would retrace. And if this ray is reaching the center of curvature, this length over here is what? Apparent height, which is mu times x. This is h. So mu x plus h is your r. So x is nothing but r minus h by mu. So if you keep the points at object slightly away from principal axis at this distance, r minus h by mu, you'll get the image on the object itself. Now, let's go to the next illustration. This is slightly tricky, interesting, but it is a very easy question. It could come in JEE mains or somewhat similar exam, or similar concept of this question could be used. But what I guess is it can never be asked in JEE advanced. It could be used in a paragraph-based question or a match the following type question, but not a simple objective question. It would have some twist in JEE advanced, but that could be just varied in other form for a JEE mains or other exams, other engineering or medical exams. Let's read that question. What happens in that question? So here you have an interface. This side is of mu1, refractive index. I can vary the refractive index of this side, right? Let's first draw a principal axis. This is your object kept here. So I can vary my refractive index as either mu2 or mu3, right? So if my refractive index was mu2, my object was formed over here. Rather, the image of the object O was formed here, O prime or O dash. And if it was mu3, my image was formed over here, dash. See, these are not the same diagram. This O dash is when I have just mu2 all over this region, and this O double dash is when I have mu3 all over the region, right? which means I don't have this thing. I don't have this, then I have mu dash. If I don't have this, then I have mu dash. So one of them is absent to get the respective images. So if you have all throughout mu2, you have mu dash. If you all throughout mu3, you have o double dash. So just mu2, o dash, just mu3, o double dash. Now, the question is, suppose I have given that upper half is of mu2, right? And I have omitted this out. Just upper half is just mu2. This is the upper half. Forget this mu3 now. What I've done is I've taken the lower half as mu3. So what will happen? Would you find an image of the object at o dash, o double dash, somewhere in between, or no object at all? I'll repeat the question. Rather than having whole of it as mu2 or mu3, what I did was upper half as mu2 and lower half as mu3. So what would be the image location? O dash, o double dash, somewhere in between, or no image at all? If you think it through, we'll understand that if I just use the upper half, I mean, I'm not doing anything wrong. All the refraction laws are valid. So all my refraction formulae are also valid, which means I definitely have an object corresponding to mu2, which is this guy. Similarly, if I just omit out the upper half, just think of the lower half, I'll have an object at image at o double dash, not an o dash. So I'll have two images, one at o dash, one at o double dash, right? And that is the tricky part over here. You have to understand that there's nothing like an average value over here. mu2 is also acting, mu3 is also acting, but mu2 is for the upper half, mu3 is for the lower half. But yeah, you could say that the intensity of image at o dash and o double dash would be reduced. Why? Because half the rays are coming to the upper half and half of them are going to the lower half.